So today we're doing 1-3 relations of functions, and I want to give you plenty of time to work, so I want to try to get through this quickly. But the stuff that we're doing in class, the stuff I do under the document camera will be recorded and will be online. So if you're absent and you want to feel like you were here today, then you could watch the video lesson and actually see us working out problems. You may even hear your best friend in class. You'll be like, oh, that was so... I feel all warm and fuzzy about it. So. All right, so let's go ahead and get that taken care of. Define those terms. Remember, one book per table. That's all we have room for here. I'm going to follow along and go with this here. Define a relation. What is a relation? You volunteer. I'm going to try to call on names that I don't necessarily know right away. Some I will know right away. All right, hold on.
You cheating.
Okay, Madison.
Set of ordered pairs.
Set of ordered pairs. Yes, any set of ordered pairs is a relation. So any set XY is a relation. Okay? Stop that. I'm starting to work. Like maybe it's gonna melt. I can't look at it right now. So domain. What's a domain? Tyler.
The X value of every pair.
Good. So this is your domain. X is always domain. What do we call Y then?
Range.
That's our range. Now, just like X and Y, X, Y, that's alphabetical. Domain and range are also alphabetical. Okay, pretty cool. Okay, so remember that. X goes with domain, range goes with Y. All right. Any questions there? All right, moving on. Now, study examples 3 and 4. Answer question 10 through 13 on page 23. Here we go. Give it a go. Work with your partner. That some of you may not have finished these yet, but I want to make sure we're on the right track. So, you studied the examples. Number 10, evaluate f of 4 if f of x equals x squared plus 2x minus 5. This is called a function. This is function notation. Remember, f of x is the same thing as y. Okay? And when we want to plug something in there, we have f of x. Notice this x. It's the same variable we have in this problem. Well, whenever we replace that with f of something else, we're saying, what is this when x is 4? Now, x has become 4. That means all of these x's in here also become 4. So we're substituting a value in. So what is the value of y when x is 4 is really what it's asking. So part of learning math is just knowing the language. Okay, so 4 squared, 16 plus 8 minus 5, or 24 minus 5, or 19. All right, so f of 4 is 19. And really what that means is you have an ordered pair. You have a relationship of 4, 19. Okay, this would be for those of you like, what's the answer? What do I need to put? This is your answer. Okay. But this is really what it means. The whole point of having function notation is so that you can make a relationship between an x and a y value. Okay, any questions there? All right, number 10 says, graphing calculator. Use your calculator to evaluate g of 4. I'm not going to have you use your calculator. We're going to do that by hand. If g of x equals 2x squared plus 3x minus 1. Okay, I wouldn't have you use your calculator on it because I think it would take a little longer than we need to spend on it. Plus, I want you doing it by hand. So give that one a go. Finish up numbers 12 and 13 as well. All right. Good. Time's up. All right. I'm assuming everyone put the 4 in here. So you did g of 4. You replaced the x with the 4. That's 2 times 4 squared plus 3 times 4. I'm talking now, so you can't be talking now. 4 squared is 16 times 2 is 32 plus 12 minus 1, or 32 plus 12, 44 minus 1 is 43. How many got 43? Okay, very good. That would mean we'd have an ordered pair of what? Parker? 443. Now really, what this is saying, when they say evaluate it using your graphing calculator, they're saying, okay, take your graphing calculator. In the y equals menu, put in your equation, 2x squared plus 3x minus 1. This is one way to do it, probably the quicker way, I think. Okay, so we put that in there. Now, there's a few things you have to know. First, I'm going to let you put that in. For those of you who want to do this and follow along and learn your calculator, you will be a huge step ahead of your high school counterparts next year. When you're in pre-calculus and you have class with juniors and seniors, you'll know how to do this. They will have no idea at the beginning of class, a lot of them. Okay, that's huge for you. All right, now there's a few things you need to know. First, you have not reset settings since we used this last, most of you, which means this plot, everyone see how it's highlighted up there? You need to note that that means that plot's still on. To turn it off, there's two ways. One, you can go up to the plot when it's blinking and just hit enter. That now turned it off. Or, I turned it back on. Or you could go to second y equals, which is stat plot, and the same way we turned it on, that's how you turn it off. Okay? So now it's off. All right? But if I hit graph, it's going to zoom me back to my zoom stat that I was in last time I used this. I want the standard viewing window right now, the original display I had. So if I go back to zoom, and you're going to use this a lot this year, zoom standard, number 6. That brings you back to your 10 to negative 10, negative 10 to 10. Okay? And that's my equation. Now what I'm saying here, when it says use your calculator to evaluate it, well, we're g of 4. That's when x is 4. So what I'm really trying to figure out is when x is 4, what's y? Well, if I go to my table feature, everyone point it out to your neighbor where your table feature is. Look for the word table. Okay, what is it? Yes, Colt?
Above the graph for the second function.
Good. It's second graph. Second graph. And that brings you to your tables. I want to know what y is when x is 4. Well, there's x4. What's y? Hey, we got it right. Yeah, man. Now, one of the questions, I'm going to jump down to 13 real quick. 13 says, explain why you would not use a graphing calculator to evaluate the function in example 4. I can borrow your book there. Example 4 shows this function. F of t plus 1. Now, is there any way to find t plus 1 on my graphing calculator screen for a table? Where is t plus 1 on your x-axis? We don't know. We'd have to know what t is, and we don't. You can't find the variable in here. That's why you wouldn't use your graphing calculator to evaluate that, because you can't find this amount, t plus 1, in the x part of your graphing calculator screen. Okay, so you need to know some of the limitations. Thank you. All right. Evaluate h of 2t if h of x equals 5x minus 2. How many of you have started number 12? How many are done with number 12? Okay, I'm going to give you another minute to work on number 12 there. Okay, let's give it a shot. Can I have your attention up here, please? Okay, the rule is, in here, within 5 seconds of me asking for your attention, you need to be done talking no matter what. Give me your attention. Some of you just are helping others, and I get that, but I still need you to be done at that point. So h of 2t if h of x equals 5x minus 2. So once again, x is being replaced. This time it's being replaced with 2t. So that means in your equation, every x you see becomes a 2t. That x became a 2t, and that's the only x. So we actually have 5 times 2t, or 10t minus 2. So h of 2t equals 10t minus 2. Now, that's not giving you a really nice ordered pair, right? I mean, you have a variable in there. So when x is 2t, y is 10t minus 2. Okay? But that's okay. What we have here is we've evaluated this equation, or this function, for 2t. It's 10t minus 2. Okay. Everyone rate themselves 1 to 5. 5, you think you got that part. 1, you're struggling with it. This is not an easy thing, always. Some of you will find it more difficult. Okay, and that's okay. Just make sure you're asking lots of questions. All right, next piece. We're going to take a look at answer these questions as a class. Does our data represent a function? We have a few ways to answer that question. We're going to use a mapping diagram and a vertical line test. Then there's a question on page 8, or number 8 on page 22. So everyone take a look at number 8 on page 22. It's going to help us out there. And on that number 8, what I'm going to need you to do is graph some points for me. So if you look at that, can I borrow that? Thanks. So everyone looking at it, that is number 8 that I'm talking about. Do these ordered pairs belong to a function, and how do you know? So what I need you to do is plot those points. We're not connecting them, we're just plotting them right now. Okay, plot those points on graph paper. I'll be coming around with graph paper if you need some. Okay? Your points match my points?
Yes, sir.
Okay, is this a function?
No.
Why not?
It doesn't pass the
Jaden?
It doesn't pass the vertical line.
It doesn't pass the vertical line test. Parker, what's the vertical line test?
It's when you take your pencil across, and if it comes across the line more than once at a point, it's
Good. So it passes everywhere except for right there. Okay, and that's because this x value is 1, and the y value is 2, and this x value is 1, and the y value is 4. Now, what's another way of seeing? I mean, the vertical line test is great, but it would have been nice not to have to plot the points. And we should be able to go, hey, it doesn't pass the vertical line test, we're good. What's another way? Tyler?
You could look at all the ordered pairs that you have and look at the x value and see if there's any familiarity in them, or if there's any repeating ones.
So see if there's any similarities, like if any of them are the same.
Yeah, like there's 2 ones for the x value, so you know one past the vertical line test.
Okay, good. Yeah, well, that's one way of doing it. So make sure I have these points right here. Hope you guys are checking me. You're usually pretty good at checking me. So when I make a mistake, hands go up like immediately for some people. Did I plot any of those wrong?
No.
Okay. So notice here my x's are the same. And that was the point that messed us up. That caused it not to pass the vertical line test. But here the y's are the same. Is it okay for y's to be the same? Yeah, they still pass the vertical line test. We don't have a horizontal line test, but they pass the vertical line test. So this is not a function because 2 x's go to different y's. In other words, 2 inputs, or excuse me, the same input gives us different outputs. You can't have the same input giving you a different output. Otherwise, you don't know what you get. You know, it'd be like going up to a pop machine and putting in a buck and hope you get a pop. Oh, this time you get a cookie. It might be cool if you want a cookie. If you're thirsty, it's not going to hook you up. Sometimes maybe you get like a stuffed animal. Get an iPhone one time, that'd be kind of cool. You're like pumping in the money, right? A same input has to give you the same output. Or excuse me, it can't give you different outputs. It has to give you the same output. Okay? So however you want to think of that. Some students get really messed up with it, but that's a vertical line test. Okay? We're going to do a mapping diagram as well. All right, so let's talk about mapping here. Mapping works like this. Let's take those points. So someone give me those. Here's my x. This is called mapping. Make sure I'm on the screen there so you guys copy this down. Here's my y. We just make an x and y area. Okay? Now on those x's and y's, we have some points. Let's say, for instance, we have, let's use those points. Read those points off to me again. 1, 4. 2, 6. 3, 5. 1, 2. I'm not going to put a 1 there again. I already have a 1. And 5. Ooh, I already have 5 over here too. And 7. And you said 2?
Yeah.
Okay. Notice I didn't repeat any. So 1, 2, 3, 5, 7. And so this 1 mapped to that 4. This 2 mapped to that 6. This 3 mapped to that 5. So far, so good. Okay? But then 5, what did 5 map to? 5. And what did 7 map to? 2. Okay? Where was the one that I'm missing? I'm still good right now. 1 map to 2. This one right here is going to be the problem. Now, it's not because it goes to the y, but it's because from that 1, we have 2 different rays coming off. Okay, in a mapping diagram, if you look at the x's and you see two rays coming off the same x value, then you know it's not a function as well. This is another way you're going to see it. It's called a mapping diagram. Okay, so we have a vertical line test. We have kind of just using our eyes, looking at the table, seeing if two x go, or different x's, two of the same x go to different y's. Or a mapping diagram, which is kind of the same. You're looking for the same x going to two different y's. Then it's not a function. All right, not a function. Okay. How many think you have it? Okay, well, let's see how well you have it here. With your groupies, now this is with the groupies sitting around you. I know it's tough to see, but there's our best there. Answer A through J. Is it a function, yes or no? And I'll try to slide that up just a little more. So everyone says no on letter A. Why is letter A not a function? Volunteer. Someone, Kaylin.
Because there's two of the same x values.
Yeah, those two right there, right? Now be careful. Just because there's the same x values doesn't mean it's necessarily not a function. They have to go to different y's. But this is no. Okay, letter B. Function?
No.
No. Look at all these x's going to different y's. Same x going to different y's. Letter C. Function?
Yes.
Well, hold on. X repeats right here.
They're both the same.
Good. Same y value. It's okay. So yes. How many got that one? Tried to trick you. Letter D. Function? Yes. It's okay to go to the same y. You just can't have the same x going to different y's. Okay. Letter E. Does it pass the vertical line test? Yes. So this is a function. Is this one a function?
No.
No, not a function. I guess I'm really not. It says which relations are functions. So if they are, say yes. So yes and no. Doesn't pass the vertical line test. Okay? Hits the point or the graph more. How about here?
Yes.
Yes. All right. Letter H.
Yes.
Yes. X's go to different y's. Letter I?
No.
No. Right here we got a problem. They go to different, the same x goes to two different y's. And?
Yes.
Yes. It's okay for two different x's to go to the same y. That's okay. All right. Very good. That's it. Any questions? All right. Assignment is the example side 2 through 12, and you have some on the mixed side as well. But please note the directions. It says determine whether each relation is a function. Notice these are all relations. Remember, a relation is an ordered pair. Everyone's a relation. Every one of those is a relation. It's a function if it satisfies those specific rules. And we didn't talk about this. What is this? Yeah, I heard y equals mx plus b. It's a straight. It's a straight line, and when you have an x and y in that, that means it crosses both x and y axes. Now think about your straight lines. The straight lines we have that are not functions, what type of lines are those? Yeah, Cole has it there. They're vertical lines. Any vertical line is not a function. It doesn't pass the vertical line test, which is kind of weird because it's called a vertical line. Kind of odd. It doesn't pass its own test. That's messed up. That'd be like Colt if you had a test and you didn't pass it. Your own test. You give it people in your test. Kind of weird. Yeah, but the vertical line does not pass the vertical line test. Kind of weird. Okay, but every other, and this, by the way, is called an x equals graph because it only crosses the x-axis. Every other linear equation is a function. Okay? Y equals are functions. All right, so you have that side, and then if you turn it over, please. The other side, once again, you have more, are these functions up here. Okay? I don't know. Unbelievable. Okay, we are going to attempt these problems here. This one will be kind of a little more challenging. We haven't talked about it a lot, so that's kind of a challenge problem, but I want you to complete it. It's not terribly difficult. It just means plug each of these in, so you have like you have 5 different problems you have to do here. You have to put -2 in and then solve for y. Put -1 in and solve for y. Put 0 in and solve for y. And it says find the range. And when you express the range here, express it in set notation like that. So whatever you get when you put -2 in, you're going to put right here as your first value. Whatever you get when you put -1 in, you're going to put as your second value, and so on. Graph the relation on a coordinate plane. Write the relation as a set of ordered pairs. So for instance, if I put -2 in, -5 times -2 plus 2, that gives me 10 plus 2, or 12. So my first output for that input is 12. That means my first set of ordered pairs would be -2, 12. Then show the relation in a mapping diagram. I will tell you the most difficult thing for you on this assignment will be these problems down here. These will be the most challenging, and the first few may not be. But notice as you get down here, you're like, whoa, what? Oh, I had to do f of 4 and then divide it by g of -3? Yeah, man, that means I've got to put 4 in up here and get a solution, and then I could put -3 in to the g of x1 and get a solution, and then divide them. So you got to do some math there. Doing it on a separate sheet of paper. Okay, there you go.